All right, so now that you've had a chance to look at quadratic functions on your own, you've looked at the definition, you've tried some problems with them, either by yourself or with a partner, I'm going to go ahead and go over them. So the big thing that you need to know, and I did not tell you this on the worksheet, is that this fancy definition of a quadratic function, all it's telling me is that first, take whatever you're given and try to put it in this form. So multiply, combine like terms, anything you can do to get rid of parentheses, things like that you're going to do. After you do that, all you need to know is this piece right here. This piece that tells me a cannot equal 0. If a was 0, notice they would have 0 times x squared, which would make that disappear. So in other words, I cannot have my quadratic term disappear. So all that's telling me here is that since a cannot be 0, I have to have an x squared term. If an x squared term is present, it is quadratic. A linear term can be there or not be there. A constant can be there or not be there. So if I look at these examples, I notice on number 1, there's nothing I can combine. There's no like terms. There's no multiplying I can do. I don't know what x is. So I check, do I have a quadratic term? I do, so I'm going to go ahead and say yes, this is quadratic. If I needed to identify my terms, which you will do on your worksheet, I would say that my quadratic term is 2x squared and the coefficient of my quadratic term is 2. My linear term is negative 3x, and the coefficient of my linear term is negative 3. My constant term is 4. Okay, so now let's look at number 2. Let's do the same thing. So I realize there is a quadratic and a linear term, quadratic term being x squared and linear term being 6x. I notice there is no constant term, meaning my constant term is equal to 0. But again, my definition never told me I couldn't have a constant of 0. It just told me I could not have a quadratic term of 0. So since I have the quadratic term, I'm going to go ahead and say yes, this is quadratic. On number 3, I notice that there's some things I can do. I can do some multiplying. So I notice that this is binomial times binomial. So I'm going to go ahead and FOIL it. After foiling it, I get 3x squared minus plus 3x minus 2x, which will add to be x, minus 2. So I skipped some steps here since our focus in this video is not on foiling. But this is the product that I get after doing that FOIL. So again, all I really need to do is check and see, do I have a quadratic term? I do, so I say yes. Again, just going through some extra steps because you will have to in your worksheet. I can identify my quadratic term as 3x squared, and the coefficient on my quadratic term is 3. My linear term is x, and the coefficient on my linear term is 1 since nothing's written. And my constant term is negative 2. And because there is no variable, we really don't have a coefficient part. It's just the constant term. Looking at number 4, I'm going to do the same thing as I did on number 3 in the aspect that I want to kind of clean it up and get it in that standard form first. So I notice there isn't anything in front of the parentheses, so I don't have to worry about doing any kind of distributing. So I can drop the parentheses and combine like terms. And I get 4 equals x squared plus 5x minus x squared. So I combine my like terms. If I have an x squared and someone takes an x squared, I have no x squareds left. I'm also going to bring my constant over to the other side because I notice in my form up here, I do have all my terms on one side. So I'm going to subtract 4, and I get 0 equals 5x minus 4. So I check. Again, according to my definition, I have to have an x squared term. I do not have an x squared term, so I'm going to go ahead and say no, that is not quadratic. In fact, if I wanted, I could be even more specific and say it's actually a linear function. It's in the form mx plus b, where I have a y-intercept of negative 4 and a slope of 5. Looking at number 5, 5 is very similar to number 3 in the aspect that I'm going to have to do some multiplying first. So I'm going to recognize that I'm going to write this twice in FOIL. So this is going to become x plus 2 times x plus 2. Again, since the focus of this video is not on foiling or multiplying, I'm going to go ahead and just tell you what that's going to become without going through the steps. I will get x squared plus 4x plus 4. I have a quadratic term, so I'm going to go ahead and say yes, that is quadratic. And finally on number 6, again, I see I have a quadratic term. It does not matter that my linear term and my constant term are both 0. No big deal. All I care about is my quadratic, so I'm going to go ahead and say, yes, this is quadratic. So, big thing with quadratics, make sure you have a quadratic. Now, if you have a degree bigger than x squared, say an x cubed, you would not say it's quadratic. So, the highest degree always wins. So if x squared is your highest degree, it's going to be quadratic. Next thing I'm going to talk about in this video are a bunch of definitions, and then I'm going to have you watch a second video where I go through how to work each of the definitions or how to use them. So I will try to go through these fairly quickly. Standard form. We just talked about that. That's at ax squared plus bx plus c. Again, a cannot be 0. So the next thing we want to talk about is, I kind of squished all these together, so let me take it piece by piece. First one being shape. The shape of a quadratic equation is going to be a parabola. A parabola is going to look like a U. It could be a right side U, or it can be an upside down U. That's going to be our orientation, whether it's up or down. So the way to determine the orientation is to look at your quadratic term and the coefficient of your quadratic term. So if the coefficient of your quadratic term, which according to the definition we call a, is greater than 0, our parabola will open up. If it opens up, it will look like this. If, however, my coefficient of my quadratic term is negative, so less than 0, then it will open down. We can also refer to this as, is our vertex a maximum or minimum? Well, notice if it opens up, I have a minimum point here, whereas if it opens down, I have a maximum point here, and that's going to become more important when we look at the range down here. Next thing we want to talk about is axis of symmetry. It's just going to be the imaginary line that divides the parabola in half. There will be a formula that goes with the axis of symmetry that you will have to memorize. I noticed that my axis of symmetry is going to be a vertical line, which means every single x value is going to be the same on my vertical line. For that reason, my formula is going to be x equals negative b over 2a. It is important to have the x equals to represent that it is an equation. The other thing that's important about the axis of symmetry is it allows us to fold our parabola up, which also means it allows us to predict a point. If we know a point, it allows us to predict another point. And basically, that point's reflection across the axis of symmetry. So, for example, if I'm told that 5, 2 is on the parabola, say this is 5, 2, I went over 5 and up 2. Notice that the other point on the parabola would be back 5 and up 2. So my x value becomes opposite and my y value stays the same. Next thing we need to talk about is the vertex. The vertex is either going to be our lowest point, or if it opens down, like in this problem here, our highest point. So the maximum or minimum of the parabola. The nice thing about the vertex is it's also going to have a formula, but the axis of symmetry will always go through the vertex. For that reason, the x value of the vertex is going to have the exact same formula as our axis of symmetry. So once you find the axis of symmetry, you've actually also already found the x value of your vertex. Well, since the vertex is a maximum or minimum point, it has to be x comma y. Points always have two values to them, x comma y. So in order to find the y value of my vertex, I'm going to have f of negative b over 2a. All that means is you take your x value and you plug that x value. So plug your vertex's x value into your equation to solve for y. So that's what that f of negative b over 2a means. Just a couple more things. The domain is going to be all the possible x values that we can put into our function. We're going to learn later that we can have domain restrictions if we have radicals or denominators. For now, if all we have going on, which is all we have in a quadratic function, is adding and multiplying or subtracting and multiplying, we don't have to worry about any restrictions. So we can use any real number for our domain. So all real numbers will be our domain. However, our range is going to be all possible y values. Well, if I look at these two pictures up here, notice that if my y value of my vertex is a minimum, then all other y values are going to go and be above that minimum value. So what I can do for my range is say that if I open up, then my range is going to be all y values greater than or equal to my vertex. Whereas if I open down and I have a maximum point, then I'm going to say my y values are all less than or equal to my vertex. Since since that is my top point. And then finally the last two, and then this video will be done. I know it's a little bit long. My intercepts. If I have a y-intercept, I will find my y-intercept by plugging 0 in for x and then solving for y. If I need to find an x-intercept, I will plug 0 in for y and solve for x. So notice this is the same thing that we did with linear equations. In the next video, I'm going to show you how to use all of these. The only one I'm not going to show you is x-intercept. That will come after, but we will look at all the rest of them. So keep this handy. Again, like I said, in class, you will notice that this is going to be up on the wall in a big tree diagram. So if you didn't get a chance to write it down now, make sure you get that tree diagram copied down into your notes. And you will be required to be able to use all this information. And again, in the next video, I'm going to show you how that works.